So let's say you're given the function 7 all over x plus 3 quantity plus 2, and it's your job to identify the asymptotes and to discuss the domain and range of this function. I'm going to help you do that by looking first at the parent function. Our parent function in black is technically f of x equals 1 over x, but we know that when you transform it, there are several places inside the function that can change. Now, if we compare our transformed function to the function we've been given, we can see that instead of a, we have a 7, and that's a vertical stretch. So if I want to make my parent function closer, I would make that a be a 7. Now you can see it's about the same shape. Stretches and compressions do not change the location of our asymptotes, however. And they don't change our domain and range. So let's look further. In the denominator, we see we have x plus 3, which takes the place of our x minus h. Now, if we make that h be a plus 3, it would have to be minus a negative because your x is a liar. So that means our parent went negative 3 over. Already it's starting to look closer. But let's go back. Let's go back to 0 for a second. Now, when we translate left or right, there's an asymptote that's going to move 2. And as h changes, so does the asymptote. Oh, there we go, 3. This means my asymptote is right here at the line x equals negative 3. So now we have a vertical asymptote at x equals negative 3, just because of this translation right here. We have one more transformation that happened. The next change, our final change, is an outside change. It's a plus 2. So normally we see a plus k, and that's going to translate it up or down. Let's make our k go plus 2. And now we see we've mimicked our original graph completely with our transformation model. But there's something we're forgetting. I'm going to put the k back where it was. There's one more asymptote that we should be checking, and that's the horizontal asymptote that separates the top and bottom pieces of our graph, and it moves when k moves. So when we go up to that plus 2, our asymptote changes from y equals 0 to this line here, and it's y equals 2. So this graph has a vertical asymptote at x equals h, or negative 3, and it has a horizontal asymptote at y equals k, or y equals 2. The domain is going to be every x except this one here. It can't take on the value of negative 3. X can't be negative 3. So you would say x not equal, all real numbers, x not equal to negative 3. The range, all of our y values, we can have any y we want except for this asymptote right here, and that y value is y equals 2. So you would say your range is all real numbers, y not equal to 2.